In this question, a hydrocarbon dodecane C12H26 is cracked, producing three products X, Y, and Z. X is an alkane, Y and Z are both alkenes, but different molecular weights. We are going to see which statements about X, Y, and Z are correct. Let's look at statement 1. If Y and Z are but1-ene and 18 respectively, X will be hexane. Dodecane C12H26 undergoes cracking, forms X, Y, and Z. If Y is but1-ene C4H8, Z is 18 C2H4. So what is X? The number of carbon in X will be 12 minus 4 minus 2. Because the total number of carbon atoms in X, Y, and Z will be the same as the number of carbon in the original hydrocarbon. So there are 6 carbon atoms in X. The number of hydrogen in X will be 26 minus 8 minus 4. So the number of hydrogen atoms in X is 14. Molecular formula of X is C6H14. X is hexane. So statement 1 is correct. Next is statement 2. If X is butane, then Y and Z could both show cis-trans isomerism. Before checking on the isomerism in Y and Z, we will find the possible identities of Y and Z first. X is butane, 4 carbon, 10 hydrogens. So the total number of carbon in Y and Z will be 12 minus 4. And the total number of hydrogen atoms in Y and Z will be 26 minus 10, which is 16. The question says that Y and Z are 2 different alkenes. So Y and Z cannot have 4 carbon atoms. Because if Y is a 4 carbon alkene, Z will also be a 4 carbon alkene. So let's try other combinations. The smallest alkene will be 18. If Y is an 18, 8 minus 2, there will be 6 carbon in molecule Z. Z will be hexene. Let's increase 1 more carbon in Y. If Y is propene, there will be 5 carbon in Z molecule. Z will be a pentene. Now we have 2 sets of possible identities of Y and Z. Now let us check if both of them could show cis-trans isomerism. We will start with set number 1, ethene and hexene. For a molecule to show cis-trans isomerism, each carbon sharing the double bond must be bonded to 2 different groups of atoms. In ethene, every carbon is bonded to 2 hydrogen atoms, which are the same type of atoms. So ethene will not show cis-trans isomerism. So we do not need to check the cis-trans isomerism in C6H12 because statement 2 says that both Y and Z show cis-trans isomerism. As long as one of them doesn't show cis-trans isomerism, Statement 2 is incorrect. We can move on to the second set. If Y is propene, the carbon on the left is bonded to two hydrogen atoms, same type of atoms. So again, propene will not show cis-trans isomerism. So the conclusion is, if X is butane, at least one of Y and Z could not show cis-trans isomerism. So statement 2 is incorrect. The next one, we are supposed to check if statement 3 is correct. But before I explain about statement 3, we look at the answers. A will be 1, 2, and 3 are correct. B will be 1 and 2 are correct. C will be 2 and 3 are correct. D, 1 only is correct. Statement 1 is correct. Statement 2 is incorrect. So the only possible answer for this question will be D. So during the exam, if you are able to find the answers before checking on all statements, you can use this strategy to save time. For now, as usual, we will check if statement 3 is correct. Statement 3 says that X could be octane. So if X is octane, X contains 8 carbon, 18 hydrogen. So the total number of carbon in Y and Z will be 4. Total number of hydrogen in Y and Z will be 8. The smallest alkene will be an 18. So if Y is an 18, 4 minus 2, the number of carbon in Z will be 2. The number of hydrogen in Z will be 4. But question tells us that Y and Z are alkenes with different molecular weights. So X could not be octane in this question. Statement 3 is incorrect. So for this question, only statement 1 is correct.